Alright guys, so we are on the second section of chapter 2 now. So we should have talked yesterday about the different theorems that we have when two lines are parallel. So before we start, remember, take notes. Alright, if there's something that you get stuck on, do me a favor and highlight it or put a star next to it. That way you can ask me in class tomorrow, but make sure you're writing everything down. Okay, so before we start into the new stuff, we're just going to recall what we went over. So remember that alternate interior are going to be on the inside and on opposite sides. Okay, so when we look at this diagram that's up above, alternate interior would be like angle 7 and angle 4 and angle 8 and 3. Okay, and we also know when we have alternate interior angles that they end up being equal. Okay, so I'm just quickly reviewing what we know about these angles. Alternate exterior, those are going to be the same type of scenario, but they're on the outside and opposite sides. Okay, so we look up at that diagram and that's going to be angles 1 and 6. And also angles 2 and 5. And we also know that those are equal as well. The third one we're going to look at, make sure I can still see the diagram, is going to be corresponding. Okay, so those are ones that are in the same spot. Okay, so that's going to be angles 1 and 3. Oh, that was a terrible angle sign. Angle 2 and 4. Angle 7 and 5. And angle 8 and 6. And again, getting repetitive, we know that corresponding are equal. Now this last one is the only one that ends up not being equal. So consecutive, those are on the inside, but on the same side. Okay, so we're looking at angles 8 and 4. And angle 5, oh, I lied. What am I looking at? Angle 3 and 7. And those are going to be supplementary. Okay, recall that that means that they add up to 180 degrees. All right, so that should not be new information to you unless you didn't watch the video the night before. All right, this is all stuff that we went over and we should have practiced a little bit in class. All right, but make sure that you're really getting used to, one, knowing what theorem is where, so what locations we're looking at, and also knowing, okay, what does that mean about those numbers? All right, so what we're going to look at now is on the flip side. So yesterday what we did was we started knowing that the lines are parallel, and because they were parallel, we know that those theorems were true. All right, now we're going to flip that a little bit, and we're going to say, well, what if we are trying to prove that the lines are parallel? Okay, what we can use is we can use converse theorems. So what that means is we flip the theorem to prove it the other direction. So it was similar to when we were working with biconditional statements. It was true both ways. Okay, so when we look at alternate interior, our original theorem was if two lines are parallel, then alternate interior angles are equal. Okay, so I'm going to write that over on the side for a second. So if two lines are parallel, then alternate interior angles are equal. Okay, so when we find the converse, remember the converse means that we flip it. So I'm going to say that if alternate interior angles are equal, then two lines are parallel. Okay, so I'm going to erase this original one over here. So what we're doing is we're taking that original statement and we're flipping it. That way we can use that to prove that two lines are parallel, because it's not always going to tell us. All right, so alternate exterior, our original was if two lines are parallel, then alternate exterior angles are equal. So I'm going to flip that. So the converse would then be if alternate exterior angles are equal, then two lines are parallel. Okay, so same thing, we just took the original theorem and we flipped it in order to prove something different. Okay, so I'm going to, instead of writing, you guys should understand what I'm doing here, so I'm just going to write the theorems for the next two. So consecutive angles, we know that those are the ones that are supplementary. So I'm going to say if why is my marker messing up? Okay, let's try this again. So for consecutive angles, if consecutive angles are supplementary, so that should be the only difference here. So if they are supplementary, then the two lines are parallel. And for corresponding, we should remember that corresponding angles were equal. So if corresponding angles are equal, then two lines are parallel. Okay, so those four right there, all we did was take the original theorem that we worked with yesterday and we worked with at the beginning of this chapter, and we just flipped it. That way, instead of proving that angles are equal or angles are supplementary, we're using that to prove that the two lines are then parallel. All right, so we are going, did I already do interior? Yeah, I don't know why that's written there. Okay, so we're just gonna skip over that. Okay, so what we're going to do is we're going to look at this and say, okay, how can we use these? So this tells me if angle 4, so I'm going to mark this, if angle 4 is congruent to angle 6, which theorem proves that L is parallel to N? All right, so we can't just look at lines and say, okay, well, they both look like they'll never touch, so we're just going to assume that they're parallel. They could be slightly not parallel and you'd never be able to tell. All right, so we have to look at those angles and figure out, okay, what type of angles are those? So they are on the inside and they're on opposite sides, right? So that's going to be alternate interior. But remember, because we're proving that the two lines are parallel, we have to use the converse. So we're going to say converse of alternate interior theorem. Okay, remember I abbreviate theorem with THM. Okay, so alternate interior theorem, if we use the converse of that, that's going to prove to us that those two lines are parallel if we know that 6 and 4 are the same. All right, next it says if the measure of angle 3 equals 4x minus 6. All right, so we're talking about angle 3 right here. And the measure of angle 8 equals 2x plus 18, so this angle right here. For what values of x is A parallel to B? All right, so we're just going to look at that part first. So those are alternate exterior angles, right? They're on the outside and they're on opposite sides. And we know that if those lines are parallel, so we're trying to prove that those lines are parallel. If they are, what does that mean about the angles? Well, that means that they're going to be equal. So what we're going to do is we're going to take the 4x minus 6, and we're going to set it equal to 2x plus 18. Okay, and I'm going to go through and I'm going to solve for x. So I'm going to subtract 2x from both sides. And I get 2x minus 6 equals 18. Add 6 to both sides. And I'm going to get 2x equals 24. Divide by 2. X equals 12. So what that means is when x equals 12, so I'm going to write this. When x equals 12, that means that angle 3 is going to equal angle 8. Right? And what would that mean? That would mean the lines are parallel, and it wants you to say which theorem justifies that. Well, we know that if angle 3 and 8 are equal, then they're alternate exterior angles, and that would mean that the lines are parallel. So we're going to say the converse of alternate exterior angles theorem. Okay, so this shouldn't be super difficult as long as you understand what we went over yesterday. All we're doing is taking the converse and we're flipping that statement and using it the opposite way. We're using it to prove that lines are parallel instead of proving that angles are equal or supplementary. All right, so make sure that you got those notes written down. Tomorrow in class, I would recommend you having, I'm going to star them. I would recommend you having all 4 of these written down and in your notes. That way you can use them during the activity until you start to get the hang of it and you start to memorize it, okay? So remember, bring the notes. If you have questions, highlight it, put a star next to it, circle it real big, do what you need to do. That way you remember to ask questions tomorrow, and we will do some practice with this.